Okay, this is your Stat Sensei, and we're going to do scenario 2 for one sample proportions. We're going to run both a hypothesis test and a confidence interval. So for a particular shopping mall, 60% of the visitors spend over $25 when they visit the mall. So we have a claim of 60%, all right, or that's the status quo. That's what things have been. The mall was recently remodeled, and the shops are trying to determine if the percent of visitors spending at least $25 has changed. A simple random sample, oh, there we go, that's important, of 550. That tells me this is my sample size in leaving the mall showed that 64% had spent over $25. Well, that's interesting. But here, they've actually given us a p-hat, all right? So, provide statistical answer to, evidence to answer the vendor's question using a hypothesis test. Well, the claim is that they spent 60%, or that was the status quo. We took us, so we have to define our parameter. And our parameter is let P equal the true population proportion of mall shoppers who spend at least $25. Condition, they told us a random sample was given. Matter of fact, it was a random sample of 550, and that was given. N is less than 10%. So basically, we're claiming that there are at least 5,550 shoppers at the mall. I don't know if that's true, but probably holiday time definitely would be true. All right. Then NP, 550 times 0.64. Well, what did I just do there? There was my sample size times my p-hat, 64%. So 352. Well, 352 is greater than 10. So we met that part of the normality condition. Please remember, we have to meet both parts. All right. And 550 times 1 minus 0.64, all right, is 0.36, and that's 198, and that's greater than 10. And by the way, I call these two conditions the Goldilocks. Not too big, but big enough. All right, we need a sample that's not too big, but big enough. Those are the Goldilocks conditions, all right? So we're going to go ahead and write our formula. Z equals P hat minus P naught Q naught over N. And it was great. They already gave us the 0.64. That was in the problem, minus the population 0.6. And so we can set up our formula not all nice and easily. I go stat test, one proportion Z test, and I have my P naught, and it's like, okay, they told me it was 60%. Then they asked for my X. And whoa, that was my number of successes. They didn't give me that. Where did that come from? Well, P hat equals X divided by N. So in this case, we know that P hat is 0.64 equals X over 550. And when I solve, I end up getting 352. So I go 0.64 times 550. If that had not been a whole number, we would have to round. All right, if it had been 352.3, round. All right, round to a whole number. Otherwise, it will not run. All right, let's actually do that without a whole number. 352.3, and then 550, and then we needed a not equal, and we calculate, it wouldn't run. But if I go second quit, stat test, one proportion Z test, and I make the 352, it will run. And the reason is the binomial is discrete. We're using the normal approximation for a binomial. Because it's discrete, we have to have counted data. All right, so there's my Z-score, 1.914. Now it's a positive Z-score, so I'd be shading up in this direction. But we ran the two-tailed test, so just as extreme as 1.195 is negative 1.915. So that's why we had to put the 2 in front. So please don't forget to put the 2 times. Right, so this needs to be 2 times that. And when we did that, we ended up getting a probability of 0.0555. And at an alpha level of 0.05, our p-value is greater, so we're going to fail to reject. So our conclusion, our p-value is 0.0555. We failed to reject a null. There is not sufficient evidence at alpha equal 0.05 to suggest that the true population proportion of shoppers who spend more than $25 has changed from the original 60% or is different, all right, has changed or is different. We cannot say that the remodel changed the percentage of shoppers. This is basically answering the question. So we always need to give a summary and then we need to answer the question. Explain the meaning of the p-value in context. P-value, the probability that we get a test statistic this extreme given the null is true. There is a 5.55% probable chance that we get a test statistic this extreme or more favoring that the percentage of mall shoppers had changed. This is from the alternative, when in fact the null is true and the percentage spending is still 60%. That's a restatement of the null. What type of error? Well, we failed to reject. And if you fail to reject, the only type of error that we could have committed is a type 2. A type 2 is failing to reject a false null. In this case, we would believe that the percentage of shoppers spending $25 had not changed when in fact it had. As a consequence, the mall owners will not be able to charge the shops higher rents. All right, so that's the hypothesis test. Let's look at the confidence interval for the same problem. We're going to move a little bit more rapidly through this problem because we've already established what it would be if we were doing a null. Please remember this part was optional. This is if we were doing the hypothesis test. We do have to write the parameter. We do have to write the conditions, but we just did that on the previous part of this, so we're not going to spend the time doing it. So then we're going to go back to our confidence interval, a formula, which is p hat plus or minus z star, p hat, q hat, n. And they wanted us to run a 99% confidence interval. That requested a 99% confidence interval. Okay. And so I need my p hat. Please remember, p hat equals x over 550 equals 0.64. Let me redo that. P hat equals x over n, and p hat was 0.64. X over 550, and we solve when we get that, but they already gave us that value. I need to pause this for just a moment. Well, I'm glad I took a look at this. We have a typo here, or actually wrong values. This should not be that. This should be 0.64 plus or minus. You know what? Plus or minus, we'll come back to the z star. This is 0.64. This is 1 minus 0.64, which is 0.36 over 550. All right. Now, please note, I use p hat and q hat here because we don't know the 60%. We're looking for we're actually looking for the mean. We're looking for the new mean. So because we're looking for the new mean, I have to use the p hat. So 0.64 and 0.36. And I need to calculate my z star. Second vars, inverse norm, parenthesis 1 minus 0.99 divided by 2, mean is 0, standard deviation of 1. And I got 2.576, which is our z star. So that would be what we're plugging in. All right, so let's go ahead and run the test, stat test. We're gonna have to scroll way down to letter A, one proportion z interval. And we know we have an x of 352, an n of 550, but our confidence level is 0.99. and I end up getting 0.587 to 0.693. And we are 99% confident that the true population proportion of mall shoppers spending more than $25 lies within this interval. Because 60% lies within this interval, we do not have sufficient evidence to say the remodel changed the percentage. Okay. And in repeated sampling, we expect this method will capture the true population proportion of mall shoppers spending more than $25 95% of the time. So in repeated sampling, we expect our method to capture the true population proportion. Please make sure you always do these in context. Make sure you always include them in context. Otherwise, you don't get credit. All right. Appreciate you watching. Hope that helped. And we'll see you in the next one. Thank you.